a great honor for me to be the first talk, so ask to be the first talk at this great workshop. It's been my dream for many years to come here. Yeah, so Eliane and me will be talking about our experience with using functional programming with real artists. Yeah, so talk about experience and also give you a little demo of the stuff we did. Yeah, so Eliane is a student, or was a student until recently, of my master's student, and both of us work at the OST. Maybe some of you know the OST. That's a university in Eastern Switzerland, one of the major universities in Eastern Switzerland. But maybe many of you know it from Zurich, which is an event that takes place there that we co-organized for the last 8 years. So who's been to Zurich? Wow, nice. For those of you who haven't, please, I welcome you to please join. It's it's 3 days. It's free for participants, and we have a lot of fun there. Good, but these aren't the only two people involved in this work. So actually the people in the center of this work are two artists who you see on the screen right now. This is Soren Thors and Farhad. They are quite popular in the art scene because of their robotic artwork. So they make a lot of art that moves around. And one of the specialities that they have is that these artworks have a certain, or they sort of give a certain emotional state to the person who's seeing it. But better than me talking about it, I'm going to show you a little video that they have. I'm going to put my microphone just 1 minute.
The next work is a sound-sensitive installation that we affectionately call complicates. And we wanted to work with the notion of being surrounded by a tribe of very shy and sensitive and sweet creatures. So how it works is we have these panels which we have on the wall, and behind them we have these little creatures which hide. And as soon as it's silent, they sort of creep out, and if it's even more silent, they stretch their legs out, and at the slightest sound, they hide back again. So we had these panels on 3 walls of a room, and we had over 500 of these little pygmies hiding behind them. So this is how it works. It's a video prototype. So when it's quiet, it's sort of coming out from behind the panels, and they hear like humans do or real creatures do. So they get immune to sounds that scare them after a while, and they don't react to background sounds. You'll hear a train in the moment that they don't react to. But they react to foreground sounds. You'll hear that in a second. So we worked very hard to make them as lifelike as possible. So each pygmy has its own behavior cycle, mood swings, personalities, and so on. So this is a very early prototype. Of course, it got much better after that. And we made them react to people, but we found that people were being quite playful and childlike with them.
Yeah, so I met Farhad and Soren Thors many years ago, I think about 6 years ago, and I was always thinking, wow, this is really great artwork. And I sort of asked them, what's the engineering that goes behind this? And I was surprised to see that a lot of the stuff they do is at a higher level than what most engineers do. And I was thinking, wow, this is really complicated stuff. And I asked them, was this easy to do? And they said no, and they were struggling with it. And this is quite natural, right? Because this is a lot of low-level work. There's a lot of low-level hardware work. It's all in C, or it was all in C some time ago. Yeah. And so all this is written in a very low-level imperative style. But they have so high-level behavior intertwined with this low-level code. It was getting really hard for them to maintain, really hard for them to write. And so over many years I was thinking, let's do something together that sort of gets people out of this misery. So this was the original motivation for this work. So artists have a very strong aesthetic drive for beauty and elegance in their work. Since we're in Milan, I chose these pictures to depict that. And so there's a little parallel to this. So there's functional programming, that's what we're here for. That is a style of programming where elegance, simplicity, and clarity are really highly prized. And so if you take this logic a bit further, it's not implausible to say that all artists should then be functional programmers. But they are not, right? Why are they so reduced to writing this low-level imperative code? So this was the main curiosity that drove me to start this work. And because of the position that I am in, I can use students, abuse students to explore these curiosities. And so, yeah, so this is the topic of Eliane's master thesis. But this is not all. How many of you know this really great textbook for learning Haskell? So the Haskell School of Expression. Yeah. So I think that's really, it was really great. It's learning functional programming through R. That's really great. And also, the very reason that we are here at this workshop, at the FARM workshop, is also evidence of the fact that there is a lot of synergy between art and functional programming. Can I ask how many of you are artists? Whoa, nice. Yeah, so that was how this works out. So in this work we try to use functional reactive programming, and we try to see how well art has accepted this form of programming. So FRP, I guess most of you know this, but just a one-line summary of what that is. FRP is a style of programming for implementing reactive systems using the principles of functional programming. So it started almost 30 years ago. So there was an ICFP paper in 1997 from Eliane and Robotic on this. This was pretty much, very groundbreaking at the time. And it had some very nice ideas. So to make time explicit, have some basic building blocks that you can combine using nice algebraic laws. It had very nice stuff. And so this paper created somewhat of a revolution and led to a very large number of further attempts to do FRP. To some dissatisfaction of its first author there, who has since moved on to write some of the greatest papers in this area anyway, so in our field. But yeah, so this was the story. But I didn't see any artists using this, so I was thinking, maybe we could sort of bridge the gap. So, yeah, so now I'd like to ask Eliane to show you some of the special things of the artworks that we did. So we did a number of artworks with them. Eliane's going to talk about the edge beams right now, which is one of their newer artworks, but we've also worked on the pygmies what you've seen. So it's not called pygmies anymore, it's called Untitled, because of some reasons. But yeah, Eliane, please.
Thanks. So I would like to introduce you to the artwork edge beams and show you some insights in our code design using FRP in Haskell, and to talk about impressions of the artist about your work. So you can see here a sketch of edge beams. This is an artwork consisting of panels that are mounted to a wall, and you see these black shapes that or creature living behind these panels. The idea of the artwork is that if you are observing it, you will observe some social dynamics between these beings. And these beings belong to groups, and only one group is allowed to be outside at a time. And each group has a suppressor, and if a suppressor is stronger than the current group that is outside, the group has to hide, and the suppressor on its own can emerge. There is also a motion detector sensor, so if you're stepping too close to the artwork, the beings are aware of your presence and they start to hide and just peek over the edge and hide again until you step back. In an imperative style, you would typically send commands to the motors, like go from the hiding position to the peeking position or something like this. But in we use another approach, which is typically for FRP, where you build signals for each being containing the current position of the being. So this position is sent continuously to the outputs, to the motors. So if a being should stay at the same position is sent again and again. And if a being should move out, for example, the position is increased step by step and sent to the motors. There's also an input signal containing the data about the motion detector events, which then changes their behavior. The artists usually use a Raspberry Pi that controls all the panels, and they have a framework called Atlas in Python, which controls normally also the behavior, but in our case now just motors and sensors. So we just added a Haskell service which runs the FRP code written in Yampa in Haskell, and there are these behavior that is started and produced the positions. Then we send the input data of the sensor over a WebSocket to this behavior and gather it into a signal, and then the output positions are sent back to the motors, to models which use the motors. This design also allowed us to replace the physical hardware with simulation because it's decoupled, so it was really easy to just connect something else to it. The simulation enables testing without access to the physical hardware. And you can see it here, it's a pretty simple web framework, web UI. And you can see there are also parameters where the artist can test out some different behaviors and see the reaction immediately on the screen. So let's have a look at the simulation. You can see here the social behavior of the beings. So at the moment one group is outside and the others peek over the edge and hide again. And now on the left you see the suppressor coming out. Now the merges on the other have to hide. And now the group of the suppressor is allowed to come out, and the other beings just peek over the edge and hide again. The architecture also enables an immediate reaction to the parameter if you're changing the parameters. So normally you would, in imperative style, you would send a command move from one position to another, so it would be really hard to change this movement during the movement. And with architecture, it's easy because the position will just increase if you increase the velocity. You can see it here, maybe focus on the being on the left side. So it will start really slow, and when the velocity is increased, it increases the velocity immediately. But when you look at it again, it's being on the left side. The others also react to it. You can see it very clear. So let's have a look at our code or at the design. Big advantage of FRP is that it makes it really easy to write code that is close to the problem description. So for the being behavior, this would be that you have the social behavior of the being, and when a motion event appears, the behavior changes to disturb behavior, and if there is no motion, it will change back to the social behavior. You can see it here in the code written in Yampa. So we start with the social behavior until the motion event happens, and the behavior switches to the disturb behavior, and after no motion event, it will switch recursively back to the social behavior. Let's have a look at the social behavior. This is different depending on the role of the being, if it's a suppressor or a normal being. So for the suppressor, it looks like this. The suppressor just has a check behavior, which means it looks over the edge and hides again. It does this until it has the highest rank of all that are things that are outside. And then it will change the creep out behavior and is allowed to go to the standing position. If nothing happens, the suppressor will hide again after some time, that other groups are allowed to come out. Or if there's a higher rank, not higher rank event because someone else is coming, it has to hide. too. For the normal beam, it's similar, so it checks until its group is allowed to come out, and then if the group is not allowed to be outside, it will change back to the check behavior. After we tested our code in the simulation, we also were able to test it on a physical prototype. You see here the social behavior. These two beings belong to one group and are peeking over the edge. Because they are the only group, they emerge to the standing position. And now at the top there's a suppressor coming out as soon as it emerges the other half. And now they're just allowed to peek over the edge until the suppressor is gone. We also implemented the steer behavior when a motion event happens, but the physical prototype doesn't have a motion sensor yet, so it's here just a key press. But you will see as soon as the key press happens, all of the beams have to hide. They just peek over the edge. Now they hide. Now they just peek over the edge. The modular architecture that we use enables the simulation, which uses the same behavior code as the hardware, and this enables testing, which is an advantage for the artist. And it also makes it easy to switch between the different hardware setups. For example, you see here another prototype which looks like the untitled hardware that is at the beginning. It's working like that, but it should be only one creature that peeks over the edge at a time. And now we connected the edge beams control software with it, and it doesn't matter if it has a sound sensor and different motors, it also works the same. So you can see here, one group is outside, and on the bottom the suppressor appears. And then the being on the left has to hide, and on the right the being is allowed to come. Another advantage is the code, because it's more understandable than the artists are used to from the imperative style that they use. They were really impressed that it's possible for them to read the code and understand it. This is because it's close to the problem description. And they told us that this is an improvement for them because at the moment they have to tell the developers what they want, but they cannot control what they did because they are not able to read the code. And this style of coding can improve the collaboration between artists and programmers. If you are interested in our work, we have 2 papers in proceeding, an experience report and a demo paper. The experience report also contains more insights into the code. And yeah, for us, we saw that FRP offers many technical advantages for programmers, but at the moment we don't think that it's possible that artists program it by themselves. The problem is that you need an understanding of FRP and, for example, Haskell to code with it. So there's a need for interfaces that hides the complexity from the artists or from people that are not very experienced with programming. But better collaboration is possible between artists and programmers. For example, we would recommend a pair program so the artist can tell what he wants or what she wants, and the programmer can do it.
Thanks, Eliane. So we started this work with the aim of observing how well real artists would accept programming in this style. And at the end of this work, we think that it is still possible to keep the dream alive, and that functional programming may one day allow artists to express beauty and elegance, not only in their end work, but also in the code that runs this end work. It's like a scientific engineer that I was talking to just before I came, he said, conquer the world through beauty. And I think that's a nice note to end this talk. Thank you very much.
Yeah. So the previous artwork, the one with...
Oh, one second, straight, there's a mic coming here.
Oh, sorry. Yeah. So the previous artwork, the one with like the spoon, so that one has an imperative to young. And was that one written by the artists themselves, or was there a similar collaboration with a programmer?
Yeah. So the initial artwork, which used to be called Pygmies, then Islanders, and now Haskell, that was already written in a low-level C language. Our first collaboration with the artist was to duplicate the behavior using FRB.
Yeah, I know, but my question is, that one, like before you guys even talked about
yes.
That one, did they, the two artists, did they write that software on their own without any programmer collaborators?
Oh, I know, I think they had help. Yes, I'm not 100% sure, but they did have help.
They have a development team that goes with them.
Ah, okay, because I was going to say that in some sense, the step backward, you suddenly you need a programmer and before that they could just hack it together themselves, but then, okay, cool.
Yeah. Are there any questions? Other questions?
Sorry, I didn't mention to interrupt while we have more questions. I did not hear my phone because this is not going to be broadcast to those on remote viewing. Do you have a demo portion after this, or is this conclusion for the whole slot?
This is the whole slot, yeah.
Well, please do continue your questions. I'll also just say we're going to take about a 3-minute additional break after this talk to see if we can get the audio issue resolved.
Thank you, ma'am.
Very cool work. Thanks. It's kind of a broad question. So I see this as could be seen as an evaluation of the beauty of Haskell in general. So we use these oracles, these artists who are really good at judging beauty and quality, into judging now these functional programs. I'm wondering if we can do something the other way. So get feedback back to them, so we can improve our images. If we can somehow make them even more beautiful.
Yes. Yeah,
What are your thoughts on this?
No, that's a very good question. Yeah, that is a very good question. So till now, the artists actually, they always said that we'd like something graphical. Somehow they're really into having it graphical. But I've always thought that, hey, of course, there's only so much you can do with a graphical interface, right? And I'm thinking that, then we sort of make our box and they have to live within this box. And I think that using a textual, sort of algebraic way of doing things just opens up the freedom into all this. But somehow I think we do need maybe better tutorials, maybe a language which is more suited. But yeah, this is a very good point that maybe we should try to mold our languages from their perspective as well. Yeah. And of course, there's always this also, I don't know why, but there's this sort of intense tension between artists and mathematics and algebra. Not everywhere, but this is something that we did face, right? They said that overall, the moment you say the dirty A or algebra, people get a bit upset. So we have to go to this a bit slowly. They have had many years of bad experience in school. Thanks, man. Great session.
I'm afraid this is more common than a question. So, first of all, erroralized DSLs do lend themselves to graphical expression, right? We've done projects completely outside the artistic domain, but that might be something to do. But generally, it seems you seem unsure of what user group you're trying to target, right? And in a lot of arts that have artifacts associated with them, right? There's the artist herself, and then there's some person actually implementing or building the thing, right? So I've noticed that working in stage lighting. We also had for complicates as well, where I came to the conclusion that it was unrealistic that the lighting designers would actually use the language, but instead it would have to be somebody else. And the work might be a little bit more effective being focused on one group or another rather than with this tension.
Yes, I understand. Again, this is the conclusion we came to as well. I said that, okay, now at this point in time, we need something like a pair program, and both of them set up the same table, and say, okay, I want this, and each one does that. But the distant dream is that maybe not. I don't know.
But is this really desirable? Right? Is this really what we? I'm not sure of that, right? That's really what
Yes, that's valid. Yeah.
Any more questions? One last one? Let's thank the speakers.